Hello my dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have learnt about call by value with a program. In today's video, we will see call by reference. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. So let us see the difference between call by value and call by reference. So call by value we have seen in the previous video. So what it says, in the call by value method, we pass the actual value itself as the function argument. So we pass the actual value as actual argument in the function call, and we receive that with formal arguments with new variables. So memory is wasted. So we need to create new memory to receive that. So here actual value will go, right, in the function call, and we receive that with new variables, means memory is wasted. And as we receive that with new variables, whatever changes we do in the called function is reflecting to that new variable. It will be reflecting to that new variable. So whatever changes we do in the called function, whatever changes we do in the called function will not reflect in the calling function. This is what is the call by value. But what about this call by reference? Reference means what? Address. So here we are not passing the actual value as argument in the function call. We pass the address of the variable. That is a speciality. Reference means address. We pass the address of the variable. So when we are passing the address, obviously we have to receive that with some special variable, and that special variable is pointer. So we will have the small discussion on pointer in today's video. Well, we will have separate video for pointers itself in the next coming videos. We'll have separate videos for that. But whatever essential thing we require for this particular topic, only that part we'll discuss here in today's video. So we use pointers. What is this pointer? What it is going to do? We'll see that. Okay. So memory is not wasted here. So as we are sending the address and that address is being received with pointers, whatever changes we do in the called function will reflect in the calling function, because I'm straight away dealing with that same location. I'm not receiving that value with new variable. I'm receiving that address, receiving the address with pointer variable, where the pointer variable will be pointing to that. How it is going to receive the address, how the pointer is going to point to that address, that we'll see now. So we are having some special thing here. We have a special variable, that is pointer variable. So we will have pointer variable to receive the address. Okay, so that we can point to the same location. So when I am pointing to the same location, whatever changes I do, it is to the same location itself. I am doing in the same location. So how we can do that? We'll see that. That is what we call by value and call by reference. Actual value, but no. In the call by value, in call by reference, we pass the address. How to pass the address? Let us understand with a simple program. Again, the same program, that is swapping of two values we have taken. That is swapping of two values using call by value we have seen in the previous video. Now we will see using call by reference. Now, this is what the function declaration. The function name is swap. The return type is void. Taking two arguments, just look at here. We have two arguments, both are of integer type, but it is a pointer type. How do we make out that it is pointer? A pointer variable is represented by asterisk symbol star followed with the variable name. So when the compiler encounters a pointer variable, it can understand that it is a special variable that receives or that holds address. Okay, so we have two variables, both are of integer type and both are of pointer. So what is this pointer actually? Let me tell you in a very simple way. Pointer is a very, very important topic that what we have in the programming, and this particular topic or this particular concept, that is pointers, will be used in data structures very effectively. So what actually this pointer is going to do? The name itself tells you pointer. It is going to point to a location. A location means to an address. So pointer is a special variable. So what is pointer? A pointer is a special variable. Why it is called as special variable? Because it can hold the address of another variable. It is special variable because it can hold the address of another variable of same type. So what is this pointer? It is a special variable that can hold the address of another variable of the same type. Another variable of the same type means, say for example, if I say I want to point to an integer variable, then pointer should also be an integer because it should know that to how many bytes it has to point. An integer pointer can point to integer variable. A float pointer can point to a float variable, like that. That is what the meaning. It's a special variable. Why it is called as special variable? Because it can hold the address of another variable of the same type. How do we represent that? It is represented with asterisk and variable name. So for example, I say PTR. So I say int PTR. So it is of integer type. So integer pointer. So now this integer pointer can point to an integer value. So for example, I say int a equal to 10. So I need to store the address of this a into this pointer. So we should have some initialization. How do we do that? I say this pointer variable ptr equal to store the address of a. How do we represent the address? The ampersand operator, address operator, that is ampersand of a. So what the compiler will do now? It is going to assign the address of a to ptr. So as soon as the compiler encounters these two declarations, it is going to create one pointer variable of integer type and an integer value, and 10 is stored in that. So a is an integer value. So some address is there for that. Some address 100. What is the value? It is 10. Then I have a pointer variable, that is ptr, and when the compiler encounters this pointer initialization, what it is going to do? It is going to assign the address of a to ptr. What is the address of a? 100. Store that in ptr. So ptr will have 100. Well, this pointer variable will also have some address. Don't worry about that. But what it is going to store, that matters. See, here a is a normal variable that is storing some value. And ptr is a special variable, which is pointer variable that is storing some address. So when I say ptr equal to ampersand of a means store the address of a into ptr, means this pointer ptr is pointing to this location. When I just say print a, I get 10. When I just say print ptr, I get 100, the address. What is the value at that address? Then I need to say asterisk ptr. Asterisk represents value at location. Value at location or address. ptr means if I just say ptr, it is 100. When I say asterisk ptr, means value at that location. ptr is pointing to 100. What is the value at that 100? It is 10. If I simply print a, I get 10. If I simply print ptr, I get 100. If I print asterisk ptr, value at the location, again it is 10. Hope you have understood this small explanation on pointers. Well, we will have a detailed explanation on pointers in separate video. Okay. Just know what is pointer. It's a special variable that is going to point to the address of another variable, one constraint of the same type. That you should remember. It's a special variable that holds the address of another variable, but it should be of the same type. How do we represent that? With asterisk symbol. Okay, so two notations we use, one is asterisk and the other one is ampersand. Ampersand represents address, asterisk represents value at that address. Got it? So with this, we will understand this program now. So here asterisk P and asterisk Q, this is declaration, this is call and this is definition. Hope you all know this. So as soon as the main function gets executed, we have two variables declared. So let me write that. A, which is initialized to 10. So some address, it is 100. Again, B, it is declared and initialized. You can also take some values if required. I have simply initialized. If you want new values, you can take that also. As usual, enter two values, scanf percentage D and percentage D, twice ampersand A, ampersand B, that you all know. Well, I have initialized the value, so A and B are initialized. So as soon as the compiler encounters the variable declaration, it is going to allocate the memory for that based on its data type. If it has been initialized, memory will be initialized with the value. Okay. If not, during runtime, we'll take the value. Okay. Then some message. So in the output screen, let me write the output screen. The first message I am going to get swapping. Okay, and a new line will occur. This is what the function call. This is function call. As soon as the compiler encounters function call, the control will be to the declaration to check whether the function is declared or not. And now observe here, I am sending the address of A and address of B. Ampersand represents address. What is the address of A? It is 100. So what I am sending? 100. What is the address of B? It is 200. This is what the address. Okay. So in the previous program, we sent the actual value itself. So in the function call, what do we send? In the function call, we send the actual argument. Right. So in the actual argument, we say we are passing actual values in call by value. But here we are not passing actual values. We are passing the address of the variable. Address of A and address of B. So when I am sending the address, I cannot receive that with normal values or normal variables because it is not normal value, it is address. So when I am sending address, I have to receive that with special variable, and that special variable is pointer variable. So as soon as the compiler encounters this function call, it is going to check, oh, address is being passed. Then I need to receive this with pointer variable. So look at the declaration. So I have pointer variables. This is what the formal argument. So in the actual argument, I am sending address. In the formal argument, see here you can simply say asterisk asterisk. In the definition part, you can have the variable names. That is also good. And if you get confused, if you want to mention the actual variable name, you can just have that in the declaration part, in the header part itself. So here we have the formal argument, which is pointer variable, because this is not normal value, this is special value, which is address. I need to receive that with pointer. So yes, of course, after function call, everything gets matched with declaration. The control will be to the definition part, this part. Okay. So now P, let me represent here. So I have a pointer variable P and I have a pointer variable Q. P is receiving 100 and Q is receiving 200. Okay. Let me write it here. P is receiving 100 and Q is receiving 200. So what should I write here inside the P? It's a pointer variable. I am receiving 100. Q is receiving 200. Means to say it is pointing to this location and this is pointing to this location. P means 100. Q means 200. Right. Well, of course, even this pointer variable will also have some address. You can just have some address, say 400 and 500. We don't want that. We only want the address that what it is holding, what it is storing. So P is storing 100 means it is pointing to the location 100 and Q is storing 100 means it is pointing to the location 200. Now, so this is swapping code. You know what is the swapping code. So we have a temporary variable as a temp equal to, look at here, asterisk we say. Asterisk represents value at the location. So value at the location, sorry, I have to write P here, asterisk P and here it is Q and here it is Q. Temp equal to asterisk p means whatever we have in the asterisk p, value at the location p. P means 100. Value at that location 100. P is pointing to 100. Value at the location 100 is 10. Store that to temp. So temp is getting the value 10. Then value at the location q, store it in the value at the location p. Q is pointing to 200. Value at the location 200 is 20. Store that in the value at the location pointed to by P. P is pointing to 100. In this location 100, I have to store the value that is pointed to by Q. Q is pointing to 200. The value at 200 is 20. Take a copy of that. Store that in the value of the location P. P is pointing to 100. You store 20 here at the location pointed to by P. Then whatever value I have in temp, store that in Q. Temp is having 10. Right. This is what the local variable temp that I am using here for swapping purpose. I am storing 10 there. Value at the location temp. Whatever value I have in temp, store that in the value of the location Q. Q is pointing to 200. Value at the location 200, I should store the value that what I have in temp. Temp is having 10. So that 10 will go to value at the location Q. Q is pointing to 200. Value at the location 200, store 10. See, whatever I am doing with the actual location itself. I am not taking extra variable, normal variable and storing the values in that new variable. I am storing the values in the actual location itself through pointers. This is what pass by reference or call by reference. So whatever changes I did with the actual location itself. See, P is pointing to 100, Q is pointing to 200. See, value of A and B interchanged. So this changes that what I did in the called function reflects back in the calling function. So this complete part is done. The control will be, see, this flower bracket program subfunction is done. Control will be back to this place. Then the next statement gets executed. So my output will be A equal to print integer that is stored in A. So what is A? See, this is what? A. Right. What is A? It is 20 interchanged value. Then space B equal to print the value in B. What is B? This is what? B. What is B? It is 10. Got the interchanged value? See, initially A was 10 and B was 20. Now A is 20 and B is 10. This is what? Call by reference. Hope you have understood this. Call by reference method. So now let us see the actual execution of this program.
Program for call by reference. This is what the function declaration. Look at here. So in the declaration we have the pointer variables P and Q. We have initialized A and B to 10 and 20. Then this is what the function call. We are sending the address of A and address of B. The control will be to the definition part. Receiving the address of A into P, pointer variable P. Receiving the address of B in the pointer variable Q. Then we have the swapping code. This is what the swapping code. The values of P, Q, that is value at the location P, that is the value of A, value at the location Q, that is the value of B, gets interchanged. Then the control will be back to this place. Then I'm going to print the value of A and B. So whatever changes I did with the location of A and B itself. A value gets changed to 20 and B value gets changed to 10. So let us see the execution now. Let us save the program. Then control F9. See, A is 20 and B is 10. Swapped value. So this is what? Call by reference. So whatever changes I did in the called function, it gets reflected in the calling function. This is what the calling function. So here in the calling function, I sent A and B, the changes got reflected. This is what calling function and this is what the called function. Changes that what I did in the called function reflects in the calling function. This is what? Call by reference. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.